Another term that you'll hear commonly throughout this course is biotensegrity. Describe biotensegrity principles as they apply to the human body or biology. With a tensegrity structure, there are two primary components. We have struts, which provide the compression element, and then we have cables, which provide the tensional element. For the sake of the human body, the bones can be seen as these compression structures or these struts, whereas the surrounding tissue, predominantly the connective tissue, can be seen as the cables or the tensional elements of the biotensegrity structure. Now, importantly, biotensegrity is a construct of human movement. What we are all very familiar with and what our academia is developed around is the movement construct of biomechanics, and where biomechanics resides from the Newtonian principles and how those are applied to the human body. For the biotensegrity component, what we can think about is how the body is essentially distributing compression and tension as we go throughout different movements. Now, again, importantly here, these are not opposing or supplemental views. As far as I'm concerned, these are interrelated constructs of movement that each have their own aptitude or application for how we are observing movement, prescribing exercise, or evaluating an injury for certain cases. The reason why biotensegrity is so commonly associated to fascial anatomy or fascial discussions is because of a lot of parallels between the two. We've talked about how fascia provides this three-dimensional continuum throughout the body. And when we look at a biotensegrity structure, we again see this distribution or trade-off of compression and tension. And the important thing with this is how each component has a direct relationship or influence on the adjacent components. I think this is one area where biotensegrity has a very beneficial view for how coaches or practitioners observe movement, because with our conventional biomechanical anatomy, it is structured for us to be very isolated in how we utilize or view this biomechanical structure. We break the body down into these independent segments, and then we study it independently, only to then try to relate it back to the body thereafter. Biotensegrity works a little bit differently, where it's all kind of omnipresent, or in other words, we're not trying to isolate certain components and then bringing it back to see how it relates to something else. We're looking at this in more real time, where we want to see how the positioning of a foot affects the arm action during a sprint pattern. Furthermore, we can think to biotensegrity for the sake of stress distribution and then the shared stress throughout the body as we go through different mechanical actions or excursions. Ultimately, with biotensegrity, we're thinking about energetic systems that are highly efficient and are able to distribute or share stress across different structures for the sake of durability and longevity.